All right, so we're just going to have a fairly quick lesson on how to do ray diagrams with mirrors. And so we're going to start off with an object that is going to be to the left of the mirror. So I'm making it so that way this is a concave mirror. It is the inside portion here that is going to be the reflective side. So here we have our object. It's going to be just an arrow. It doesn't matter what it is. And we're going to draw some rays coming off of the tip of that arrow. So let's go ahead and do that in a few different colors. So each color will have represent a different ray. So the first one will come off parallel until it hits the mirror. Then once it hits the mirror, it's going to reflect, and it's going to go through the middle of the focal point and go off into the distance. And so that's the first light ray that we will draw. The next one will go through the focal point before even hitting the mirror. And I'll put that one in red, it doesn't really matter. So that'll go through the focal point until it hits the mirror. And then from there, it will go parallel to the principal axis. So just in my head as I go through this, I will usually just kind of say to myself, parallel focal point, parallel, just as a little bit of a reminder as to what happens there. And those really are the only two rays you have to draw. The cross section, where they cross after hitting the mirror. Obviously they cross here as well, but that's not what I'm concerned about. I'm concerned about where they cross after both of them have hit the mirror, which would give me this location here. So if this location here represents the initial point of these light rays coming off the object, then this point here represents the same spot but on the image. And so then that means that this is going to be the image right there. It is inverted. Because it is inverted, it is real. Light rays actually do go to that location. And if this is the base of the object, then the base of the image will also be on the principal axis. So where these light rays converge, that's going to be the tip of the image. I can do a double check with one more light ray. And I'll throw that in hunter green, sure. Where that would go to the center of the mirror. And basically you can think of it this way. At that location, the mirror is essentially a flat planar mirror, a flat mirror. And so any light ray that hits that location would reflect, because of the law of reflection, it would reflect in such a way to where the angle that it comes in at relative to the principal axis is going to be equal to the angle that it leaves at. And so basically this angle here should be equal to this angle here, and they look quite equal, so that kind of serves as a double check that it's in fact going to the same location. So that is how you do a ray diagram with mirrors, where we have the object farther away from the mirror than the focal point. Next, I'm going to do one where the object is closer than the focal point. All right, so now we're going to try the same thing, except with the object closer to the mirror than the focal point. So I'm going to move it here somewhere. It doesn't matter exactly where, just as long as it's between the focal point and the mirror. And things are definitely going to change in this case. Right off the bat, I'll let you know that it's going to be a virtual image, and it's going to be upright, so things change. Okay, so let's start off with just some various colors here. Okay, so in this case, I'm going to have one that is going to be parallel, and then through the focal point, and that unfortunately is going to be the only easy one in this case, and in fact even that one isn't quite as simple. I'm just going to kind of leave it at that for the moment. The next one that I'm going to draw, and I'm going to come back to that one in a minute, by the way. The next one I'm going to draw is going to go away from the focal point, so I'm kind of cheating a little bit by starting at the focal point. You'll see here in a second. So it goes exactly away from the focal point until it hits the mirror. okay? Because the light rays have to hit the mirror first before anything happens. It goes away from the focal point and then parallel. So it'll go from there and then parallel. And you notice that these light rays are diverging away from each other. So since the light rays never converge into a spot, there's no real image. So how do we even show where the image is? Well, in this case, it's a matter of line of sight. So if this is your eyeball, right, you have eyelashes and everything, so here you are looking at it, then if your eyeball is here, you see the light ray coming from a location, and I'm just going to do it by hand. You see the light rays coming from this direction. And so what we do is we take a straight edge and we trace backwards with a dotted line to show where the light ray appears to be coming from. And then I'll just go ahead and do this one from hand as well. If your eye was here, then you would see the light ray coming line of sight. So the tip of the arrow is here and here. So that's where the light ray would actually hit your eye from. So if you trace backwards from that spot, you would have a line of sight, and then where these 2 points cross, that is where the image appears to be. And so since the object has the base at the principal axis, then the image will also have its base at the principal axis, and the tip of it will be here at this location. So this is where the object will be. It's going to be upright, it's going to be large, and it's virtual, which is why when you take your face and you put it real close to one of those mirrors, it appears as if the image staring back at you is really large and it's behind the mirror. Okay, and then for the last one for mirrors, we now have a situation where it's a convex shape, where it's the outside of this that is the reflective surface. I have the object, it doesn't really matter where it goes in this case, whether it's farther or closer than the focal point. In fact, truly, this isn't even the focal point here. The focal point's actually on the other side in this case, but I always tend to draw those on either side anyway, just out of habit. At any rate, this is going to be a little bit different. So again, we're going to have some lines with dots on them because it is going to be a virtual image. So let's go ahead and draw these out. Focal point, parallel, parallel, focal point. That still does apply, but it does operate a little bit differently. Okay, so we're going to go parallel until we hit the mirror, and then it is going to reflect off. Kind of imagine for a moment where it's going to reflect. If this is the surface, it is going to reflect off in that direction somewhere. So perhaps you recognize that it's going to actually reflect away from the focal point. And so that's what I'm going to have it do, is I'm going to have it go precisely away from the focal point. Now I'm using my smartboard, so I'm going to cheat a little bit so I can do that. I'm going to start it like that and just move this guy over because that's how it's going to reflect. And I'll come back to that in a minute. For the other one, it is going to go towards this focal point, but it's going to stop short, obviously, because it's going to hit the mirror. Focal point parallel. So from here, it is going to reflect out and go parallel. And just like before, where we had our eyeball, eyelashes and everything. Wow, that's a terrible eyeball, but I'm sorry. So if you're here, it appears as if the light ray, I'm doing my best to make it actually parallel. It looks like the light ray comes from, this line of sight that goes beyond the mirror. And then for the other one, the same thing. If your eyeball was here, line of sight, it would appear as if this thing, if you trace it backwards, it would appear as if it's coming from that direction. And the cross section between these two is going to be where the image is. So since the base of the object is at the principal axis, the base of the image will be at the principal axis, and it's going to be upright, it's going to be virtual, no light rays actually get there behind the mirror, and it's always smaller with this kind of mirror. And it doesn't even matter if this object is over here or here. It doesn't really matter so much. It's going to pretty much always give you a very similar result of it being upright, virtual, and small. And so those are the 3 different examples of our mirrors. Of course, there is that one other light ray that we could do, same as before, where it would hit the center, and then whatever angle it hits at, it would, come out at a similar angle, and you can kind of serve that as a double check, whereas you trace backwards, it should hit the same spot. Because again, if your eyeball was there, it would trace back line of sight to that location. So there's your 3 examples of mirror diagrams, and hopefully that was well done.